Do we all agree that this is a rational function? It's 5x squared over 2 times x squared plus 4, which means that there is a possibility of a horizontal asymptote, there is a possibility of a vertical asymptote. Now, what is the horizontal asymptote for this function?
So is it 5
Very good. It is 5 over 2. Care to enlighten Connor?
It's because the degree of the exponents on the x variable are the same.
So the exponent here, x squared, and the exponent there, x squared, they are equal to each other. And both of them are polynomial functions, so we simply divide the leading coefficient. The leading coefficient of x squared is 5. If you distribute that 2 inside, the leading coefficient of x squared would be 2. So the horizontal asymptote would be 5 over 2. What about the vertical asymptote?
Do I have to set the denominator to 0?
We have to set the denominator equal to 0. Now, if we set the denominator equal to 0, x squared plus 4 would equal 0, which would mean x squared equals negative 4. Take the square root on both sides. What is the square root of negative 4? It's imaginary. We will get negative plus or minus, sorry, not negative, 2i. Right? It's a complex number. What does that tell us?
There's no asymptote.
There is no vertical asymptote. So we have a horizontal asymptote, but we don't have a vertical asymptote. It is feasible because for some rational functions, the denominator may not become 0, and here it doesn't. So we don't have a vertical asymptote, which is a great thing. Now we have to find intervals where the function is increasing and intervals where the function is decreasing. How do we find intervals where the function is increasing?
You have to find the critical number.
We have to find the critical number, and how do we get the critical number?
I can find the derivative.
Find the derivative and then set that equal to 0 and solve for x. So, guys, the pros are finding derivatives by now. I'll just ask a question and give you some time to find the derivative. What rule should we use to find the derivative?
Quotient.
Quotient rule. So I'll give you a couple of minutes. Let's see if we can get it right. So to find the first derivative, we can use quotient rule. The numerator is u. I'm going to show you a trick. So we have 5 over 2, right? Both of them are constants. Eventually, since we are setting it equal to 0, they would simply get, multiplied by 0, and they're just going to go away. So let me just rewrite the function. Like that. Okay? And I'll just take the derivative of whatever that is inside and multiply that 5 over 2 later on. Because you can multiply a derivative by a constant. You may ask me, well, why should I even bother? Well, these are small numbers, 5 over 2. Imagine you have a problem where you have 113 divided by 271, right? Do you want to multiply all those large numbers? Even with a calculator, it's too much work. So I'm just going to take the derivative of the inside part. So u is x squared, v is x squared plus 4, u prime is 2x, and v prime is also 2x. Good. And the derivative now, you can't forget that 5 over 2. Denominator is v squared, so x squared plus 4 squared. Numerator, v u prime, so x squared plus 4 multiplied by 2x. Minus u v prime 2x. So distribute, we get 2x cubed plus 8x minus 2x cubed divided by x squared plus 4 squared. What happens to those two? Those two would get cancelled, correct? And we have 8x in the numerator. Now we have to set this equal to 0 and solve for x. What is the very first step that you would do when you try to solve for x?
Another reciprocal.
Of,
5/2.
right, so you're first going to multiply by the reciprocal of 5 over 2, which is 2 over 5, or it's the same as saying I'm going to divide both sides by 5 over 2. So eventually that's going to go away, correct? And that is the reason why I pulled that 5 over 2 out, because it is going to go away. So when I set that equal to 0, I would end up getting simply 8x divided by x squared plus 4 squared equals 0. A word of caution. I have seen students waste time by trying to expand that by foiling. It is unnecessary. The same reasoning. How do we solve for x? We multiply by the denominator on both sides. So we simply have 8x equals 0. Correct? Also, another way of thinking about it, if something divided by something is equal to 0, it implies that the numerator has to be 0. Correct? If it is a singleton. So x would simply be equal to 0, and that is the critical value. Can I erase that? So critical value and there is no need for us to draw any other lines because we don't have any vertical asymptotes. What should we do now? We have to
Numbers on either side.
pick an easy number on each side of 0, which is the critical value. So to the right of 0, I need an easy number, 1. We have to plug in 1 in the derivative. And again, I have seen students try to plug in the values and evaluate to get a number. Now, is that necessary? No, because all we care about is the sign of the number that we will get at the end. So when I plug in 1 here, what sign would I get? Positive or negative? Positive. The denominator is a square, so no matter what I put in, my answer is going to be positive. A positive number divided by a positive number would be positive, which means on this side it is increasing. Pick an easy number on this side to the left of 0. What should it be?
-1.
-1. Eight multiplied by -1. Am I going to get a negative number or a positive number?
Negative.
Negative. Divided by denominator is a perfect square, so no matter what number you put, you would end up getting a positive number. A negative number divided by a positive number is negative. Right? If you don't like this approach, you can plug in the values and evaluate by the number. But all I'm saying is it is a waste of time. You don't have to do it because all we care about is the sign at the end. So it's negative, so it is going to be decreasing. Exactly at 0, what do we expect to have?
Point of inflection.
Huh?
Is that the point of inflection?
No, before, we haven't gotten to the point of inflection.
Break.
A break?
At 0.
Oh, is that the maximum?
Maximum or minimum?
What's the minimum?
Is it be a minimum? So the function is sort of coming this way and it's going up that way, right? Agree? So we have a minimum there. It's actually a global minimum. And if I plug in 0, what would I get? In the original function, I'll get 0. So 0 is over there and it's going up. So let me, can I erase this side? I know that the minimum is over there, yes, and it's going on either side like that. My question to you is it going to go up that way and up that way, or do you expect a different behavior? Is it going to keep on going up?
No.
And keep on going up?
Because of our horizontal asymptote.
Very good. There is a horizontal asymptote, which simply means this curve is going to get capped at that value. What is the horizontal asymptote that we have?
5/2.
5/2, which is 2.5. So this curve is going to come, make a turn, and go that way, and that way. It's a smooth turn, not sharp. Kind of sharp. Yes? Okay, so the function is decreasing. For x in
From negative infinity to 0.
and the function is increasing
From 0 to infinity.
now we have to determine concavity. How do we usually determine concavity?
Find the second derivative.
Find the second derivative, set it equal to 0, and solve for x. Look at the first derivative. That's what we have. Imagine taking the derivative of that. Do you think it is going to be easy? No. Why? You have to square that. Then you have to find the derivative of that, which would result in chain rule. And then you have to solve and then set it equal to 0. A whole lot of things going on. So here is a question. Do you believe that I can identify concavity just by looking at that picture? Yes. So what is that concavity? Oh, excuse me. So what is the point of inflection?
0.
0, right? It is concave down here, and concave, oh, actually, it doesn't exist. Concave down, right? On both sides. So it doesn't exist. So still, it would be a point of inflection. So my conclusion, even before I go to the calculator, it is concave down for x in 0, negative infinity to 0, union 0 to infinity. Oh, am I right? I'm kind of sure, about 95% sure, 99% sure, we'll see. Can you see? So y, the original function is 5x squared divided by parentheses 2 parentheses x squared plus 4. Anytime you deal with rational functions, make sure you use parentheses properly, or else you're going to mess it up. Did we do great? Yes. So we don't even have to do a second derivative in this problem and waste time finding the second derivative. The first derivative gives us what we need. Are we clear? Okay. So here we have x squared plus 2x minus 35 divided by x squared minus 25. That looks like a huge second degree polynomial. And if we try to do quotient rule like we did last time, you would have a whole lot of terms, right? So this is where you have to stop and think for a second. Well, that looks huge. That looks funny. Is there a way to simplify this? Always ask that question. Is there a way to simplify? By simplify, I mean is there a possibility for me to get rid of some terms, right? How can I rewrite the denominator?
X plus 5x minus 5.
So I could rewrite the denominator as x plus 5 times x minus 5. What about the numerator?
X plus 7, x minus 5.
X plus 7 times x minus 5. Right? Now what happens to the x minus 5?
You go with
It goes away. And we would simply have x plus 7 over x plus 5. Good. Now, does that look easy?
Yeah.
Pretty straightforward, yes. A question to ask. Horizontal asymptote. Do you believe that this particular function has a horizontal asymptote? Yes. If so, what value?
y equals 1.
Y equals 1. Do you believe that this function has a vertical asymptote? In other words, is there a number that would make the denominator 0?
Yes.
Yes, negative 5. If you can't see it directly, you can set the denominator equal to 0 and solve for x. X happens to be negative 5. Good? Go ahead.
Yeah, so in the original problem, if you just used that denominator and found vertical asymptote, wouldn't it be plus or minus 5?
In the original problem,
Yeah.
true, but since we have a common factor, it's just going to go away,
Oh.
right? It will just simplify itself. It's like saying, okay, I have 5 times 2 divided by 10 over 4, right? Which we all know 5 over 2, right? So this is the same as saying 5 over 2, right? In other words, if things are going to get cancelled, let's just get rid of it. Hypothetically, if we weren't able to cancel, then you'd have 2 asymptotes. We have to find the critical values. Let's go ahead and find the critical values. Okay, let's find the derivative. U is x plus 5, x plus 7. V is x plus 5. U prime is 1. V prime is 1. F prime of x is V U prime minus U V prime divided by V squared. V is x plus 5. U prime is 1. U is x plus 7. V prime is 1. I meant to say U prime there. And the denominator is x plus 5 squared. That erases the sign. So f prime of x would be x plus 5. Distribute the negative. We have negative x, negative 7, divided by x plus 5 squared. What happens to the negative? X's get cancelled. And 5 minus 7 is minus 2. Set f prime of x is equal to 0 and solve for x. Which would imply we multiply by the denominator on both sides, or we cross multiply. If I did that, I would end up getting negative 2 is equal to 0. Is that a valid statement? No, not in this world. So that can't happen. So there is no critical value. So horizontal asymptote is 1, vertical asymptote is negative value. You may say, well, what could we do? All is over, abort mission. Well, don't have to. Because anytime you have rational functions, they sort of help you in terms of how the function would behave. So we have an asymptote at negative 5, vertical. And we do have a horizontal asymptote at 1. Yes? Pick an easy number, because we are trying to see the behavior of the function using the derivative. You don't have to necessarily look for the critical value, because critical values tell you if there is a minimum or a maximum. But in this case, all we have are asymptotes. So pick an easy number less than negative 5. Negative 4.
Oh, negative 6.
Negative 6. You don't have to evaluate this. You can, the numerator is negative, right? The denominator is always positive. So when I plug in negative 6, I'll simply have negative over positive. Yes, which is a negative number. Which would mean the function has to be decreasing. Right? And we have to pick a number greater than negative 5. Negative 4. If I plug in negative 4, you still have a negative number over, no matter what you put in that square, it's going to be positive. Negative over positive is negative. So it has to be decreasing. So where should I draw that curve?
Like above the 1.
Above the 1, and how would it go?
Down.
This way. Now you may ask me, well, why can't it not go that way? It would be increasing, right? And if it went that way, it can't be a function to begin with. It will fail the vertical line test. Does that make sense? So it should probably go that way. So we can conclude just by looking at the graph, the function is decreasing from negative infinity all the way up to negative 5. So we are treating vertical asymptotes as breakpoints, and even if you don't have a critical value, you can make use of a vertical asymptote to identify the behavior of the function. And if it is, and it is increasing for, it's decreasing that also, so negative infinity to negative 5, union negative 5 up to infinity. Do we have to find the second derivative and torture ourselves? No. It's pretty obvious. It sort of is going like that, which means it's concave down. It's going like that, so it means concave up. Key thing to remember is we don't necessarily want to have a U shape for us to call concave up or concave down. It's just the curvature of the curve. You know, if it sort of goes like that, concave up, if it concave down, and if it's opening up that way, it's concave up. So concave up for negative 5 to infinity, concave Does the derivative exist at negative 5?
No.
No, because it is a breakpoint. A derivative cannot exist exactly at negative 5. But can we say that negative 5 is a point of inflection? What happens at the point of inflection?
Change concavity, yeah, I guess.
Right, so it changes concavity, so it is a point of inflection. So if you go back and look at the definition of point of inflection is where the second derivative is equal to 0 or the second derivative does not exist. This is a case where the second derivative is not going to exist because the first derivative doesn't exist exactly at negative 5. But could we say negative 5 as a point of inflection? Yes, because the concavity changes. Did we do well? Did we do okay when we graphed it?
Yeah.
Yes. So negative 1, negative 2, negative 3, negative 4, negative 5. And the curve is moving along, right? It is moving along 1 on that side also. We're just not able to see it. But it is moving along 1. Are we good? Yes. Okay.